This is the Smart Buildings Academy podcast with Phil Zito, episode 224. Hey folks, Phil Zito here, and welcome to episode 224 of the Smart Buildings Academy podcast. In this episode, we are going to be discussing how to break into the building automation industry. So lately, we have had a lot of folks who are either at the beginning of their careers or who are not yet in the building automation industry signing up for our training programs. And that got me thinking, we're also getting a lot of questions around folks saying, hey, how do I break into this industry? And I know we've recorded a couple podcast episodes in the past about this, but the industry, in my opinion, has shifted a little bit since we recorded those episodes. I'm finding that you are able to break into this industry a little bit easier now without having a lot of mechanical knowledge. I know that's kind of heresy to a lot of people listening here. Whenever I say that, I tend to get flamed online about folks saying, hey, you have to have massive mechanical experience in order to succeed in controls. Now, I don't disagree that having mechanical experience definitely helps. That being said, it's not as much of a prerequisite as it used to be, and I'll explain why a little bit later in the episode. So in this episode, we are going to go through the skills required to break into the building automation industry. We're going to talk about different role types. We're going to talk about how to develop into these roles. We're going to talk through some strategies that you can take to break into these roles. We're going to talk about how to hedge the pay cut, which usually is one of the biggest things if folks are already in the field, is the pay cut going into a controls role. We'll talk about how to hedge that a little bit, and we'll talk about some common questions that we get. Everything we discussed today can be found at podcast.smartbuildingsacademy.com/224. Once again, that's podcast.smartbuildingsacademy.com/224. I encourage you to go to our website if you haven't been there recently. We've got a lot of good guides, mini courses, webinars, all sorts of stuff that you can watch for free. And then, as you all hopefully know, if you've been listening to this podcast for a while, we provide the best training in the world for folks who want to develop into building automation professionals or who are already building automation professionals and want to further develop themselves. All right, so the building automation industry comes down to a couple base role or skills that are required, and then some skills that I like to point out because I don't feel a lot of people bring them up. So the base skills required for building automation are having some baseline electrical knowledge, having some baseline mechanical knowledge, baseline IT knowledge, and baseline building automation knowledge. What does baseline knowledge mean? Let's talk through each one of those. So in baseline electrical knowledge, you need to understand basic electrical theory, things like Ohm's law. You need to understand circuits. You need to understand contacts. You need to understand relays, things like that. You don't have to be an electrician per se, but you have to understand, the difference between AC and DC voltage. Anything that a baseline single day electrical course would teach you, that's kind of the level of knowledge you need to know. Now, does having a deeper knowledge help? Yeah, of course it does. As you'll see, any of these skills, having a deeper level of knowledge for any of these skills is going to be always beneficial. That being said, I'm going to try to point out the kind of baseline aptitude, because after that point, there's marginal returns on investment, right? There's diminishing returns to develop those skills further as an entry-level professional. Now, I really hope you heard me emphasize entry-level professional, because if you are beyond entry level and you're trying to become a super amazing integrator, then obviously programming and integration and IT knowledge is going to have much heavier of an impact on your career success than maybe your electrical knowledge and mechanical knowledge. If you want to go on the service tech side, then yeah, HVAC knowledge, system knowledge, IT knowledge, electrical knowledge, all of those are going to weigh heavily on your success in that role. Like I said, though, we are going to cover the baseline. So as we mentioned with electrical, understanding basic electrical theory, understanding basic sensor types, I/O types, understanding basic wiring principles, basic circuit principles, things like that. You know what? We'll probably put together a article/guide on the electrical knowledge needed for building automation. We're working on an HVAC guide as I speak. My team is working on developing that. And so you will see that coming in the very near future. And then we'll start working on the electrical guide. All right, so I mentioned electrical. Now let's move on to mechanical. Now, mechanical is one of those things that it's a battleground, right? Folks who have heavy mechanical experience and moved into building automation will tell you, rightfully so, because it's the lever that they pulled on in order to move into their career. They will tell you, rightfully so, that mechanical knowledge is critical. Then you have folks like me who had absolutely no mechanical experience, but yet were leading a service team 2 years in. How did I do it? My capabilities that enabled me to do that were my abilities to understand systems, my ability to do systems thinking, as well as my ability to read one-line documents, able to read tech manuals, etc., and internalize that information and apply that information to a problem. That'll become a later skill that we'll talk about when we talk about those kind of less defined skills. But back to mechanical systems, you're going to want to understand systems thinking. You want to, at a minimum, understand what the system types are. So what is an air handler? What is a VAV box? What is a chiller? What is a boiler? You want to understand basic heat exchange. How do BTUs get transferred? How do they get transferred both from the heat source or the cooling source to wherever they need to go? And then how do they get transferred, from a hydronic delivery mechanism to the airstream, things like that? And the answer is through coils, right? Through cooling coils or plate heat exchangers, etc. Next, you want to understand basic set point and basic inputs that you would have associated with these systems. You want to understand basic control modes associated with these systems. In all of my career, I've never replaced a compressor. I've never replaced a fan. I've never changed a fan belt. I've changed some filters. I've never went and installed a valve. I've installed actuators on top of valve stems. That being said, I can understand how all of that works. I can explain how all of that works. I can size valves. I can size dampers. I can size actuators. I can troubleshoot if a system's performing properly. I understand the relationship of pressure to flow. I understand the relationship of the opening of the damper and realizing that it doesn't have a linear line to actual flow intake of air. So, if you open it 10%, you're not getting 10% of flow. It's just like when you're opening a valve or you're opening or turning up a fan, you have curves and these curves aren't linear. I understand these things. So you'll see a lot of HVAC knowledge that you need is going to be specifically focused on systems in theory and not really hands-on. How do I change this out? How do I go and service that? Unless you are a mechanically oriented control service tech. I want to be clear on that because there's a lot of control service techs who do no mechanical work. They do absolutely none. They may troubleshoot contacts, they may troubleshoot circuits, but they're not sitting there trying to figure out if this ECM motor works or not and whether or not they should replace it and then going and picking up a motor and replacing it. That's not as common a task for a control service tech. So you've got your mechanical knowledge and you've got your IT or your electrical knowledge. Next, you move into IT knowledge, and this is where you need to have a baseline understanding of several IT concepts. You need to understand how to turn on a computer. You'd be shocked how many people try to move into our industry and cannot simply turn on a computer, cannot update Windows, do not know how to find out what Windows version they're running. They do not understand what services are. They don't understand the basic functionalities of computers. Now, most of that can be covered in a CompTIA or a network plus course, most of what you need to know. Or you could take our IT for Building Automation Professionals course, which will teach all of what you need to know around IT specific to building automation. That being said, you want to understand how to use a computer. You want to understand how to install software. You want to understand how to set up IP addresses. You want to understand basic IT networking. What are subnets? What are routes? All of those aspects of IT. We've covered this in many, many, many podcasts. I'll try to link to some at podcast.smartbuildingsacademy.com/224. So be sure to go there. I think our resource list is probably going to be pretty long for this episode. Once you've moved past IT, then we move into basic building automation. This is where you need to understand basic building automation architectures. You need to understand basic building automation parts and pieces, inputs and outputs. What are the different types of inputs and outputs? How do you do basic controller setup and configuration? How do you do basic supervisory device setup and configuration? Now, most of this will be taught to you in your OEM training class. So whether you're Distech, ALC, Tritium, Johnson Controls, Siemens, whoever, you're going to most likely go through a baseline supervisory course and a baseline field controller course. And that's where it's going to teach you how to do things in that specific software. The big gap I see running a training business and having, I think we're way past 7,000 students now. I know that. The big gap I see as the CEO of a training business is that people learn how to do things in specific softwares. Like they go through TCP, Tritium certification program, or they go through, an Allerton class or whatever. They learn how to do it on their controller, but they don't understand the why. They don't understand the processes and the reasons and how it all plugs into their day-to-day tasks on the back end. That's kind of our niche in training. And that's really what you want to focus on, because at the end of the day, you could give me any building automation software, any software, and within a day or two, I could be, I would say, 98% functional with that software. I know that's a very bold statement, but I've done it time and time again. Will I know all of the nuances, all the little shortcuts, all the little time efficiencies? No, but could you put me on a job and say, Phil, go and set up this controller, set up this supervisory device, program it, set up the graphics? Yeah. Would it look as good and as quality as someone who's been working on only that system for 20 years? No, of course not. Would it function? Would it achieve the specification? Would it achieve the sequence of work or sequence of operations? Yes, it would. Because when you understand the underlying theory around things and you understand the processes and patterns, and that's one of the big things that I found makes or breaks controls professionals. It's all in thinking. Are you able to identify the patterns? Are you able to identify the repeatable processes? The reason a lot of you, I'm talking to the managers now, are getting calls from your technicians on, I can't get this backnet chiller to work, even though the other week you just helped them with a backnet rooftop. And they're like, I can't get this backnet chiller to work. The reason they are struggling with that is, one, they probably don't understand BACnet. A surprising amount of folks don't understand BACnet. But two, the reason why is they learned steps. They learned exact steps for that rooftop. They did not understand and learn a process. So for those of you who are looking to break into this industry, learn the processes. Always think about, how could I repeat this on something else? If I were given a controller and I did not understand how to set up that controller because I've never worked on it before, but I've worked on a similar controller, what processes could I take and apply to this new controller setup? And so let's go through that, right? Let's talk through that. And this is going to kind of bring all of that knowledge of HVAC, IT, electrical, building automation to the forefront, kind of show you what I mean by having a process-oriented mind. So you're sitting there, you're saying, okay, I got this brand new XYZ building controller. I've never used this brand before, but I know I need to figure out, how is this controller going to be powered? So I'm going to go read the catalog sheet to figure out how it's going to be powered. I know I'm going to have to connect my inputs and outputs to it. So I'm going to go read the catalog sheet, figure out, or the installation guide and figure out, how do I wire up these controllers? Are there internal jumpers? Is it externally or internally sourced power? What kind of outputs am I working with? Am I working with triacs? Am I working with 0 to 10? What am I working with? And that's that basic electrical knowledge, right? And once you understand that, then you say, okay, how does this thing communicate? Does it use BACnet MSTP? Does it use BACnet IP? Is it just pure IP HTTPS with an API? What is it? And once you understand that, then you tie back to that IT knowledge, to that baseline BAS knowledge. And then you say, okay, now I just got to figure out the software. Like, how do I install this software? What prereqs do I need on my computer? That's going back to that computer knowledge, understanding what stuff do I need? Do I need .NET Framework 4.51, 5.0? What do I need? Do I need Java? What? Once you know that, you install the software, and then you log in and you start to configure things, and you say, I know that this is BACnet MSTP, so I know I need a device instance. I know I need a MAC address. So I know I need to set that up. Oh, what kind of programming is this? Is this graphical or is this line code? If it's line code, I tie back to my knowledge of basic line code. If it's graphical, I tie back to my knowledge of basic graphical. The good news is majority of building automation programming is graphical. And I really recommend, if you're learning programming, you should learn graphical first. And then, if necessary, move to line code, because line code is in a very small amount of controls products. The majority of them are graphical. But once you understand it's a graphical programming environment, you say, okay, how do I set up my inputs and outputs? What blocks do I know? AND blocks, OR blocks, XOR blocks, NOTs, etc., switches. Those are universal across most programming languages. So you can start to build out a program. And so you have all of this process and all of this baseline procedural knowledge that you understand, that you can then apply to new scenarios. The same with that BACnet scenario. Okay, we got a BACnet chiller now. I did a BACnet rooftop last week, and I know now with this chiller, okay, it's BACnet MSTP. I figured out which version of the protocol it is. Okay, what are the rules with MSTP? Well, I know the wiring needs to be the same. I know about end of lines. I know about MAC addresses. I know about baud rate. I'm going to check all of those things. I know about device instance. I know that if it's BACnet specific, I can only write to variables and outputs. I can't write to inputs. So let me make sure I'm mapping back the correct points. I'm going to go get my points matrix from the manufacturer. These are all things you can think of without ever calling your boss. And so these are the things I would really look for with folks when I was hiring them. I would look for a process-oriented mind. I would say, okay, if you need to change the tire on your car, what are you going to do, and what tools do you need to do it? If you needed to go and troubleshoot a computer at home because it was making a funny noise, what would you do? How would you do it? So I would look for one thing that I knew pretty much everyone knew how to do, which was changing a tire. And if you don't know how to change a tire, that's kind of scary. But I would look at that because that's, testing their thinking. Then I would look at something that maybe not everyone knows how to do, troubleshooting a computer or troubleshooting a breaker at home, something like that. But I was looking for their thought process. What would they think of first? How would they procedurally think of things? And I found that by hiring people who were procedural thinkers, who would organize their thoughts and then would come up with solutions based on those thoughts, I would tend to go and hire people who would develop quite well into building automation. So from that perspective, become a procedural thinker, challenge yourself to process, challenge yourself to systemizing your approach to things. If you look at any good business, if you look at any successful person, I know that's a bold statement saying any, so I'll say most good businesses, most successful people, they are very systemized, they are very procedural, they are very process oriented. They usually have a method to their approaches. They don't just do stuff. All right, from there, we're going to move into role types. So when I look at role types, I have a couple different roles, right? I have an installer role, technician, designer, programmer, service tech, and project manager. I've listed those in my opinion of the level of difficulty to get a job in controls. So you can, in theory, get a job as a programmer brand new into building automation. Would I recommend that? No. Have I done that? Yes. My first 2 weeks within building automation, I was writing programs for central utility plants, which was a really bad idea. I didn't understand how the systems functioned. I didn't understand really how to write programs. I didn't understand all the nuances of a system from the HVAC perspective, like having the isolation valves open before you turn on the chiller. That's kind of important. So you can do it. It's going to be very painful and costly for the business you're working with. The typical pattern, though, is to start off either as an installer or a technician. Now, depending on the company, these may be the same thing, but typically installers just wire stuff up. They install the electrical devices, and that's it. I like to say that technicians are installers, but they also work on the software side. So a technician will typically either install all of the I/O and the controls and the panels, etc., or they will oversee the installation by the electrical subcontractor. And then the technician will be performing point-to-point. They'll be doing basic supervisory device setup, basic IT setup. So you can start to see the installer needs electrical knowledge, pure and simple, and the ability to read diagrams. They need a baseline level of HVAC knowledge, but not that much. Now, a technician, on the other hand, they need to have every knowledge that the installer has, but they also need to have some IT knowledge. They also need to have some baseline BAS knowledge or the ability to acquire that. And they need to have a little bit more advanced HVAC knowledge so that they understand why things are doing what they're doing. From there, we jump into the designer. Now, it is entirely possible if you have a mechanical engineering degree or an electrical engineering degree that you could essentially move into a designer role straight out of college. I think you especially if you went through our designer path, within 2 to 3 months, you would be up and running. I know that's a bold statement, but I've proven it time and time again, both with our students as well as people I used to manage back when I managed an ops team. So the designer role, you're going to have electrical knowledge, HVAC knowledge, IT knowledge, and building automation knowledge, because you're going to be designing systems. You're going to be doing things like valve sizing, damper sizing. You're going to be doing things like laying out architectures, picking parts, etc., etc. From there, we want to move on to the programmer role. Now, the programmer role, surprisingly, does not necessarily have to have the level of electrical knowledge that an installer or technician does. You do need to have good systems knowledge from an HVAC perspective. You do need to have a good set of knowledge around building automation, and you need to understand IT so that you can do that programming work. The really heavy functional areas with programming is going to be understanding HVAC systems and systems theory, and then being able to translate that into controls logic. That's really what the job's all about. Now, service tech, this is kind of the jack of all trades, and I would say the master of all trades at the same time. You know, the saying is jack of all trades, master of none, but the service tech, in my experience, to be good, has to be good at all of them. You have to have the capabilities of an installer and a technician, the capabilities of a designer, and the capabilities of a programmer, because you need to take all of that knowledge and understand how a system, and I think this is the biggest trick, the biggest kind of gotcha moment. If you are able to understand how a system looks when it's properly installed, then you will be an amazing service tech, because if you can see, and you're process-oriented, remember that, process-oriented thinking. If you can see how a system looks when it is properly installed, then it is really just an as-is to be analysis. So you're looking at, this is the system as it is, this is the system as it should be, right? It should look like this installed, but it looks like this. And then you identify the delta, and that's how you do troubleshooting. You know, I was challenged the other day because I've been asked so many times to do a service technician course. And I was talking with our corporate account exec, Brendan, and I was talking with him, and I was like, dude, I don't know how I'm going to teach a service tech course, because to me, it's so intuitive. I just look at things and I can I also have this ability with quoting jobs, with estimating. I can look at things and just kind of come up with swag numbers that are like within 2 to 3% just by looking at it. It's just an innate ability I have. And the same with service. I have an innate ability to look at something and logically say, okay, this is what it should be, and this is what it is, and thus here's the delta, and thus this is the most likely problem. And so as I started to think about that, I was like, oh, so that's what I need to teach in service is I need to teach people how to do that. I'm still trying to figure out how to teach people to think like that, but I'm getting closer. And I think that is a course that is going to sell like hotcakes once I get it figured out and get it out to the market. But service tech, being able to think about, hey, this is the system. So for example, I go into a space and the space is hot. Now, some folks may immediately go checking set points. They may immediately go checking all sorts of things, right? But you have to ask yourself, okay, the space is hot. Why would the space be hot? If the space was cool or at set point, what would be happening for it to be at set point? Well, for a space to be at set point, we know that we would have a CFM setting that accurately supplies the appropriate amount of cooling CFM to the space based on the test and balance design. And we know that that airflow would be at the appropriate temperature in order to remove heat from the space, because we know that that cold 55, 58 degree air enters the space, it absorbs the BTUs that are in the space and then transfers it out via the return duct, either back into the system via return loop or exhausting it out of the building if it's 100% outdoor air unit. So we know that. And we know that that system that is driving the CFM and driving that cold air ultimately to come in is being adjusted by a damper that's in a box that is adjusting based on a command within the controller, and that command is being driven based on a process variable, which is typically zone temp, and the difference between zone temp and zone temp set point, which will be the air, which goes into the PID loop. So we know all of these things. So we know how it should function. So then logically, we say to ourselves, what is the first thing we check whenever we have an issue? Well, the first thing we always check is that we have airflow. Because if everything else is processing properly and we don't have airflow, then it doesn't matter. So we check our airflow, and then we check our airflow temperature. If we have airflow, and we have airflow temperature, then from there, I move on to, all right, is the process variable correct? So is our zone temp correct? Is our zone temp set point correct? If that's correct, then I say, okay, let's look at the PID loop that is driving that airflow. And then we say, is the PID loop controlling the damper? And if it is, then we say, is it giving us the right CFM set point? And if it is, then we say, are we getting the right amount of CFM? And so on. And we troubleshoot through that cooling only VAV box. Very basic example, but you can see the process-oriented thought process that I took. I checked the primary variable, the primary failure point that would exist, which is that not having the airflow and the airflow not being at the right temperature. And then I back into what actually drives that airflow once I validate that I have it. So this is kind of the thinking that a service tech needs to have. And then finally, the last role is the project manager role. Now you have to decide right here, is this a technical project manager or a financial? If it's a financial project manager, the likelihood is that you could directly move into a project manager role if you have a financial background and you have project management experience. If it is a technical project manager, then you probably would want to move from what I usually like to do is technician, designer, project manager. That's kind of the path I like to go. So how do you develop into these roles? Well, an installer or a technician, you're going to directly apply for those roles. You're going to want to make sure you have a baseline level of experience. You can gain that by going to a trade school. Those usually take 24 to 36 months to move through a trade school. There's a couple good programs. I think Ferris has one. Penn College, I think, has one. There's a couple others. You can go through our technician path. Many people choose to do that because that timeline for a college program is too long and they don't want all the other requirements that come along with that. They just want pure experience. So they go through our technician path. They pick up one of our lab kits, and within 3 to 6 months, they are at the level of knowledge they need to apply for an installer or a technician role. For a designer, once again, you can move directly into a designer role. I know that kind of flies in the face of a lot of things, but if you went through our designer path and you have a decent knowledge and understanding of mechanical systems, then you could move directly into a designer role, at least a junior designer role. Programmer, this is going to take a little bit more time. I usually like folks to have 6 to 12 months experience in the field just so that they understand how all of this theory works. And then the act of actually teaching someone programming, if they have the HVAC knowledge, is not that difficult. It's really just a set of patterns that you teach people over time. Service tech, this is definitely a more experiential role. Very rarely do I move people directly outside the industry into a service tech role. If I do, it's usually as a junior service tech who is more so doing helper role, but I really hate helper roles because honestly, they're just a burden to my overhead and not really generating profit and not really generating good cash flow. So I tend to avoid helper roles as much as possible in any aspect. So typically I will take people who have been technicians in the install realm, and if they want more variability, they have a personality that loves problem solving and they want less of that day-to-day process and they want more of the variability, I will move them into a service tech role. And then project managers, as I mentioned, if you have a financial background and it's mainly a financial project management role, then you could directly move into that. If it's more of a technical role, I like to follow the path of technician, designer, project manager. I hope that this episode really helped you out. It gave you a lot of things to think about. I will be sure to include a lot of links. I will include links to some of the guides I mentioned. I will include links to some of the training programs we mentioned. I encourage you to check everything out at podcast.smartbuildingsacademy.com/224. Once again, that's podcast.smartbuildingsacademy.com/224. I believe in next week's episode, we are going to be looking at integration and just common questions. I've seen a lot of questions on the Controls and Building Automation Facebook group, as well as the Smart Buildings Academy Facebook group. And these questions, I've looked at them and then I think to myself, man, like that's the same question I'm seeing on there every week. And these questions, and this sounds egotistical, I don't mean it this way, please understand, but they're easy questions. And I find myself thinking to myself, if only you thought through a process, if only you thought through the common denominators, then you could solve this problem. So I'm going to go and parse through those, pick a couple different problems that people asked about, and I'm going to solve them, and I'm going to explain why I solve them and how I solve them, because I want people to start adopting this thinking process that I think will make their lives a lot easier. All right, with that being said, thanks a ton for listening, and I will talk to you all again next week. Take care.